Welcome to Build on AWS UAE. My name's Daniel Love. I'm a solutions architect based in the UAE with a customer focus on ISV segment. Today we're going to be talking about Graviton at AWS with a specific focus on why and how you can migrate your database service instances on RDS from x86 architectures to Graviton. So we're going to focus on Graviton today, but we'll have a specific focus on a possible strategy for planning and testing your migration. And then we'll finish off with a demonstration where we'll jump into the console and see a migration and an architecture. It's important to mention that this is a really wide subject area with a multitude of plans and strategies and different architectures that are available to customers. So making the right choice will depend on your specific use case. For further reading, which we recommend, we've put a couple of links within the description so that you can deep dive into these areas. So simply put, the CPU or the processor is the circuit that provides the calculations that run a computer. And at AWS, we provide the broadest set to our customers. Traditionally, a lot of the workloads run on Intel x86 architectures. However, for a number of years now, Graviton has been made available to customers. Specifically for relational database as a service, you can have your database running on Intel x86 architectures or Graviton. As a reminder of relational database as a service, it's a fully managed open source cloud database service. This informational slide just shows you the different database engines that are available to you. I have grayed out two options there for SQL Server and Oracle Database Server because Graviton at the current time of recording isn't available on those. So what exactly are Graviton processors? Well, they're custom-built silicon by AWS, based on ARM Neoverse cores. And using our own experience of workloads that are running within the cloud, we've been able to optimize those workloads and provide different configurations to make those workloads run and optimize on the cloud. Graviton is literally designed for the cloud. So with those optimizations and customizations, this helps AWS pass on performance increases and cost reductions back to the customer. Graviton has been around for a number of years now, as I mentioned, and at AWS we iterate on our designs. So at the moment we're at version 3 for Graviton. However, within the UAE, version 2 is available. We'll be focusing today on version 2, but the strategies still remain relevant for other versions of Graviton. Why RDS for Graviton? Simply put, it's about price and performance. And AWS has seen price and performance increases on the majority of workloads that have been migrated to Graviton. Even between the instance upgrades or the iterations of Graviton from version 1, 2, and 3, performance increases have been seen across these. Also, cost reductions have been seen between those iterations that have been able to be passed back to the customers. So should you migrate your databases right now back to Graviton? Well, the likelihood is if you did that, you would see performance and cost reductions for that. However, I'm stressed to say that this is a move to a different chipset architecture. So testing and migration strategies really need to be considered for your specific use case within this area. This is an informational slide which we have here, just based around the Postgres versions that are available on Relational Database as a Service. Just showing you the different instance types available and the different sizing available for Graviton options on Postgres. Versioning is really important when you're considering your database migrations, because with Graviton, only the later versions of the database are available for you. As a way of illustrating performance, we have two different instance types here based on Graviton. And here you can see the difference between performance in Intel and Graviton. These workloads are based on write-intensive workloads, and you can see that as the orders rise, the amount of threads that are consumed increases. And it's clear here to see the difference between Graviton and Intel for that. I will stress again, each workload does act very differently, so we do encourage testing, but we're pleased to say that from Amazon's benchmarking testing, we can see that 35% increase on those benchmark tests can be attributed to performance, and 52% performance increases on price performance. So for context, price performance is the ability of a system to deliver performance at a particular price. So how can we get this started? A good place to start is, deciding a strategy of adoption. So with any type of project, defining success criteria is a good place to start. So asking questions of, why is this initiative being driven? Who is going to be benefiting from this? Are we looking to increase performance for our customers? Are we looking to improve experience for our customers and enhance that? Are we looking to save costs for our customers? Are we looking to save costs for ourselves? And what success criteria will we have from our testing to enable us to make the choice to move this into production as well? So having an idea of where to draw the line in the sand, that we're happy that our testing is successful, we can move this to production. And once you've defined your path, defining what you're observing. So a good approach that we've seen work well with customers is the outside-in approach. So working backwards from your customers. So from a customer experience perspective, looking at things like latency, throughput, and response time, and are good in understanding what's important to a customer and defining that. And this enables you to build a good holistic picture of the application end to end before you get a bit more granular around specific metrics. Because focusing on specific metrics to start with can help you lose kind of overall focus and start fixing problems in isolation, which end up chasing around issues around. Don't be fooled though, metrics are very important to collect and to define. So defining what business level, application, system level metrics are important to consume as well. And how are you going to consume them? From where? From third parties that are running on your system to collect that data, or maybe AWS native services like CloudWatch or Performance Insights to get those system level and database level metrics. And once you've defined that, how are you going to implement into production and non-production? So for non-production, you can be testing different types of Graviton instances, and that is recommended because of the performance increases you can get. Maybe you can reduce the size of the instance that is needed on Graviton and save cost further. Defining which environment this is going into. Are you going to have a like-for-like production environment, test this on development, or maybe different types of environments as well? And what type of data are you going to be using for your testing? Real data, synthetic data, or volumetric data? And then once you're ready for production, the implementation strategy usually will be based around what architecture is deployed within that environment. So, if you have multi-AZ active passive clusters, hopefully you can have a kind of zero downtime in terms of a migration for that. But if you have single instances of your database running for those, you probably will expect some downtime for those instances during a migration. But it's very important also to mention backing up before you're doing any changes into test environments or production environments, but also having that rollback mechanism as well. So if implementation into production isn't as expected, what's your rollback mechanism going to be? So as mentioned, there's many migration strategies, and picking the right one will come down to architectures, business needs, customer needs for that. Today I'm going to demonstrate one scenario, which will be single RDS instances, as I know that not everybody has multi-availability zone active passive clusters that can provide zero downtime for these. And that may be due to technical reasons or non-technical reasons of cost. So the scenario we're going to be looking about today is a relational database as a service based on Postgres database. The architecture is a standalone instance, and downtime needs to be as restricted as possible for this. So an option could be for this instance to go into the console, have a look at this instance and modify that instance to be a new Graviton-based instance. Now, the downtime you should expect for that is the amount of time it takes for the instance to reboot for that. But can we do this better? Well, the scenario which we're going to look at today will be to have a look at your primary instance and set a read replica of that instance that will be based on Graviton. So that Intel x86 architecture will be your primary, Graviton will be your read replica. Now you can then restrict the activity to the primary database for that and promote your read replica to be the primary database for that, and then you can release the activity to go to a new primary database that will be Graviton. And the great thing about that is that you will have a rollback mechanism with your Intel instance still being present there. So we'll jump into the console and we'll see how this looks. Welcome into the console. So you can see the console home that we have open at the moment. And we want to dive into the RDS service that we have here. So, but just one thing to call out, so obviously we're in the UAE region, so if you're doing this within the UAE region, you can make that selection there. But let's type Relational Database as a Service, RDS, and let's visit this service. And when this loads, you'll see our primary database that we have listed under DB instances that we have available here. So you'll see it's a Postgres instance that we have available, located in this specific availability zone within the UAE region. And this is the instance size that we have for RDS. And as you can see there, it's an Intel-based instance that we have available for that, and that's what we're looking to change as part of this demonstration. I just wanted to call out, so the database versions of the database engines, a way of having a look at what's available within that database instance. You can go into create your database. You can have a look at the different engine versions available there, make sure that you have selected the Graviton instance available there, so then you can go up and have a look at what different version types of the engine are available to you for that. So that will give you an indication as to anything that you may need to update. But let's go back to our databases, our database that we have, our database instance that we have here. So we talked about two different methods. So obviously just modifying the instance is a way that you can do that to migrate it to Graviton. So if we go to modify, and we can select here, we can go down to the different instance types that are available. You can select M6G large, so you can say I haven't changed the size of the instance there, I'm just changing it like for like, but the G there represents that it's a Graviton backed instance. Then you can move down, there's other configuration changes that you might want to take, so turning on some more enhanced monitoring or performance insights to get more granular level detail around that. And if we go to continue here, then you have the option to apply that immediately or apply it during a scheduled maintenance window for that. As mentioned, the downtime for this would be the downtime, the amount of time that it takes for the instance to reboot. So that's what you should expect in terms of downtime for this change to happen. But that's not what we're here to do the demonstration for. We're looking to create that read replica and promote that read replica. So how easy is it to do that? So if we go into and select our database that we have here, and we go to actions, we can create that read replica here. Need to make sure that you have a instance identifier available and put your details in for that. Let's change the instance type configuration that we have here. And we want to change that to M6G large. So we're not changing for any smaller instance here, but just going like for like. But as mentioned, the G within the naming convention there represents Graviton backed based on that. You can make the configuration changes that you need for this, availability zone, whether you want it in a separate availability zone is completely up to you. Turning on any performance insights or more granular level detail around the database metrics, you have the option to do that for that, and that might be a good idea. As you're implementing this into production, you might want to monitor some of these values as this gets implemented into your environment. So we'll click on create that read replica, and you can see straight away there that read replica was being created. Now this is going to take a couple of minutes for this to create and configure. So I'll put a timer on the recording here and join you back once this is created. Okay, so if we can look at the console now, so it's taken a couple of minutes for that read replica to deploy. Made some changes there to enhance monitoring. So any kind of configuration changes, it's important to say that obviously that could impact the price of what you've deployed there. So please be mindful of those kind of changes that you're making as well. But you can see here that the Postgres instance is available. It's the original instance is based on Intel, and now the new instance, the read replica that we've deployed, is Graviton for that. So obviously now we want to go on the promotion of this read replica instance that we have here to be the primary instance for you to use. So once you've kind of done your database checks and you're happy that the read replica has been deployed to your satisfaction, then you can go ahead and maybe stop the traffic from the application to the primary database that you have selected. You can then select your read replica database here, go to actions, and go to promote for that. And obviously there's automated backups and backup windows that you can select when you go through this as well. So some more configuration changes if you need to. Okay, so we've gone through the promotion for that, so we'll give that a couple of minutes to make the change. Okay, so that's taken a couple of minutes for that to change to go through there. And as you can see here, that this Graviton database now is fully promoted to be the primary database for that. And you also have your Intel-backed database there available to you if you need to make any switchbacks and change back to the old database if there were to be any issues for there. So you can see here with the Postgres database based on Graviton, now the option here is not available for you to promote because this is the one that has been promoted already. So now it should be ready and time for you to release the traffic from the application to this database instance, and then go ahead and continue to monitor, continue to look at the metrics for how that's deploying into whether it's test environment or your production environment, to ensure that you're getting those benefits that we talked about for moving to Graviton. So thank you for joining me in the console. We'll jump back to the presentation. Okay, that was the demonstration. So in summary, what have we covered today? So hopefully we've got a bit of an understanding as to what Graviton is and what the possible benefits are of moving Intel x86 relational database service instance to Graviton. We touched on possible testing strategy and technique, and a migration strategy as well, which we've demonstrated. There are a couple of things to call out here as well. So during your testing phases, we recommend that you make sure that your operating systems and runtimes are all as up to date as possible. Also your database versions for that. And just to call out that during your testing, why not test some smaller RDS instance types to see if the performance allows you to move to a smaller instance and gain cost efficiencies for your architecture. It's quite a broad subject area that we've talked about today. So as mentioned, there are links within the description for your further reading. I hope you deep dive into this area. Thank you very much.